Hello, everybody. It's 9:37 p.m. Central Time on the 13th of September 2021. Hope you're doing well. We are here on the Earthquake 3D live stream, pumping on, as you can see here on the screen. I've been very busy the last week. Apologize for my absence, but we've been dealing with two rescued cats, a kitten and a 1-year-old cat. Just got that all taken care of today with the 1-year-old. Thanks for everybody who helped. And with the kitten, Hans, he's here in the office with the Duchess who's manning him. So if you hear movement in the background, that's a kitten. But we're not here to talk about that. Let's go ahead and turn on a display capture so you can see what I see. We've got a few things going on I think everybody's concerned about. Got a lot of people contacting me about the earthquake down here in South America. 6.0 range struck earlier today, 6.2. But most people are concerned with the mainstream news articles and the elevated alert level at La Palma out here. Canary Islands, La Cumbre Vieja. You guys may have heard of that before. I'm not going to pull up the mainstream news articles on it. There's an earthquake swarm that's going on there now. Take a look at it. Big swarm on the European feed. Hogging up the European feed, actually. So you're going to see less earthquakes in Europe because this is a 50-50 earthquake feed. That's the way the Europeans do it. So on the 50 earthquake feed, most of the earthquakes are populated here, right here at the Canary Islands. Now, for you to understand what's going on with the Canary Islands, I guess you have to know the story on the Canary Islands. We're going to go over and take a look here on good old Google Earth and go in and look down at the La Palma area here. And here it is, guys. Okay, now, they've done all kinds of studies and documentaries on the volcanoes going across this area. And in particular, there's worry that an earthquake swarm down below here could cause one or more of the islands to slide. And I believe La Palma is one of the candidates that is fractured in half, basically. Now, I don't know if that's the actual island. Have to look up more on that. But everybody's concerned about it because of the potential of it causing some kind of Atlantic-wide tsunami that could inundate the east coast of the United States. In all the computer simulations, that if this or any other volcano over here, going all the way up to the Azores here, if any one of them were to have a landslide that goes down the side of the volcano, if it's a few miles wide, or if the half the island falls in, it goes down 8,000 feet around here, pretty deep, and that would be 8,000 feet of displacement that goes down. A few thousand feet dropped in, pushes out, and the worry, of course, then goes for a tsunami to spread across the Atlantic and come over to the east coast of the United States and inundate the east coast all the way over to the mountains on the edge of the craton over here, where you see all of this. Well, I guess I need to turn off the roads. That might help. There we are. You can see the edge of the craton here. It's a wavy line structure that goes down along the eastern seaboard. So all this talk about this volcano or any of the other volcanoes fracturing in half was just talk up until an earthquake swarm struck. And now that the swarm is struck, they've elevated the alert level. And if I see an elevated alert level at any one of these volcanoes, not just the one that they're talking about splitting in half, but any of the others, of course, I would worry. It means that there's movement going on down below. But how is there movement going on down below is the question a lot of people are going to ask. So let's go take a look. Here is Europe, and we'll back it out looking at the plate boundary map. This is from the USGS. All the red lines are the plate boundaries around the planet. Of course, here's the Pacific plate going over and to the west across Indonesia. We have a plate boundary. This is the Indo-Australian plate in India and Australia. Connected over across Iran. This is Saudi Arabia, has its own plate pretty much, the Mideast. Then we go over to the west and we have a W-shaped bend into the Mediterranean that kind of branches off and goes up into Italy and dead ends at the Swiss Alps. That's not a coincidence, by the way. Where it dead ends, the mountains pile up over time as this slow-moving force shapes and uplifts onto the plate boundaries. But anyway, going to the west, you can see the plate boundary goes across North Africa, and then here we are. We're down here south of the plate boundary. The Azores out here to the west, right along it, that's the normal path the seismic takes. So the seismic flow normally goes where the red lines are. Now we have volcanoes that are down here. How? How are there volcanoes down here? Well, to understand how there's volcanoes down here and the plate boundary is all the way out here, you really just have to understand what a craton is. So, to understand what the craton is and what the outer edges of the cratons do, they start to fold and bend, and on the edges of the cratons, you get volcanic formations. Let me show you a few examples. Over here on the west coast, here's the plate boundary, and we get all the way over to here, and on the deformed edge of the craton, the purple part, we have a boatload, hundreds, if not thousands, of volcanoes that formed along the exterior edge of the interior of the craton. Let me just show you the U.S. here. Do you see them all here, all these volcanoes we have marked? Okay, they go all the way down into New Mexico and back up the west coast. But the plate boundary here, look how far in that goes. It's pretty far over, wouldn't you say? To the east? Look at the distance there. And then let's go back over to the volcano in question here. Wouldn't you say that's about the same distance, but just orientation is north and south instead of east and west? So then you have to look at the African cratons and how they stretch out. And then you have to look at other cratons, for instance, United States, on the east coast. We have supervolcanoes over here in Maine that reach out over to the east coast, actually out into the ocean. Here, up in the northeast, and the edge of our craton goes all the way out to here. So out here on the edge of Africa, the same thing's going on. It's just, well, I would say older and maybe more weathered over time on the coastal plain. Okay, so how is it all going on? There's a push that's coming across the planet right now. Over the past several weeks, we saw the biggest earthquake in years strike over here, plus 7.0 range activity. A bunch of deep earthquakes have been taking place. And those are all raised high off the globe. Okay, so it's a lot going on right now. Again, in conjunction with this, we have to wait to see. I know, guys, look, I wouldn't sugarcoat it for you. If it's going to happen, everybody on the East Coast would need to have a tsunami evacuation plan to get a few hundred miles inland and up above sea level. And look, millions of people getting out of a city when you're talking a 500 to 1,000 foot tall wave. That's what the simulation showed. Think of a 500 foot tall building. Those are like the biggest skyscrapers in New York City. Might go up maybe 800 or 1,000 feet total on the biggest. So we're talking about like one of those tsunamis that would be in like a disaster movie of some kind. That's not my take on it. This is the stuff we've all seen in the documentaries about these volcanoes in particular, and one fracturing in half, and just so happens to be right next to where the earthquake swarm is, or at least one of them. Now that's just where we're starting with La Palma. Then we get down here and we have a 6 that struck down in South America, right on the money. Again, when we're talking about 6.0 range, comes in right at the low end 6. It's not like it's a huge upper 6, 6.1, 6.2. But this is next to where our deep earthquakes have been taking place. They're raised high off the globe. And there's been a series of them over the past several days. I haven't been on, but there's been a series of 200-kilometer deep earthquakes in the 4 range. A whole bunch of them. So, 4, 5, 6, maybe even 7? Several. And then now a new 6 has struck right in the middle of the whole hot mess. You can trace the line of quakes down and around to the South Sandwich Islands, which is still moving over the past several days. It's been moving for almost a month. So, a lot of activity. That's the kitty eating in the background. If you hear a little smacking sound. Oh, that's adorable. Okay. All right, back to it. So deep quakes are going in the West Pacific at all our D points. So let me show you where the Ds are. Letter D here, deep earthquake, deep 5. And deep 4s have taken place there in the past several days. Moving over to the west, we have a letter D here at Indonesia. Stands for deep earthquakes, and the deep earthquake raised high off the globe there. Going up to the north, same thing. Letter D just at the Japan juncture on the plate boundary, which I'll show you in a second, but deep earthquake there, and then up here next to our letter D, up at the Sivoktusk in Russia, we have a deep earthquake there just north of Japan, Kuril Islands, deep 5. So a bunch of deep 5s and deep 4s. Now let me show you where they are on the USGS map. Over here. Okay, so deep earthquake here at the pinnacle tip, or the triangular shaped bend of the plate between the Indo-Australian plate and the Pacific. Deep quakes here. Going over here at this S-shaped bend in the plate over at Indonesia. Deep quakes here. Then we go up to the juncture point off the coast of Japan, like an letter H-shaped bend there. Deep earthquake there. And we get up here into the Kuril Islands and another deep quake here. All right, that's the West Pacific. Deep, 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 deep. Somewhat equally spaced across the whole mass. Down below it, each one of these deep quakes leveraging up on the underside of the plate. Think of like a lever arm. You've got a lever and you're lifting up on the underside of something. You're applying that leverage. And then there's multiple people applying a lot of leverage on other angles, but they're all leveraging in on the underside of this. Well, when you push up on the underside of something, guess what? It starts to rise. And rising happens and spreads take place of seismic activity that spread out and away from where the deep earthquakes take place. Now, I can get into what I think's going on here. Let me just go ahead and show all the new people really quick. What I think's going on down below the plates, coming up out of the magma in the asthenosphere, is this. Focused concentric standing waves that focus in on themselves. And when they do, they can't compress down into the magma fluid much and go up into the underside of the plate in several hundred miles across, a very low frequency wave coming in and focusing in on itself and hammering in on the underside of the plate. When that happens and you start getting a hammering action, it starts with just maybe 1 or 2 deep quakes, like this for instance. Imagine each one of these ripples being a new deep quake. Now when they go down and bounce off this end, they go back and feed into themselves, and it becomes what's called a standing wave. As more energy is pumped in, feeds more into itself as it reflects back, more energy is pumped in from down at the other end, and next thing you know, the wave power or amplitude, the magnitude, increases. Now notice the size of the waves. They're all about the same size, right? And they equalize in the tank. But we're talking about a tank in Mother Nature, so then that gets us back over to the plate boundary map. All the red lines are the tanks, and we get somewhat equally spaced quakes across this uneven wave tank, spreading out and away from where that hammering action is coming up from underneath. It starts where the deep quakes are. So we have, again, deep quakes up here at Kuril, deep quakes here at the H-shaped bend at Japan, deep quakes down here at the S-shaped bend in Indonesia, and deep quakes over here at Fiji. Jump right across the plate, parallel, and we have our deep quakes over here at the U-shaped bend, or the bent portion of the plate on the east side, going over into South America, and that's where the 6 struck as well. So a bunch of deep quakes hammering off on the opposite side of the plate over here. This whole side and this side. But wouldn't you say, this of course is not part of the Pacific directly, and neither is this. But those two are somewhat parallel to each other across the plate if you, again, take the curvature of the Earth and the rotation and angle in question. And of course, there's going to be people who debate that, by the way. Oh, no. The flat earthers. Okay. Anyway, so I'm keeping my voice down because we've got the kitten in here, by the way. So looking at this across, we see deep earthquakes hammering up and spreading out and away. Then it comes up through the plate, this very low frequency, and it drops off. Let's get back to the video here. Drops off the same sized earthquakes all the way along the way. And when it moves, when the wave moves, each wave peak fills in the previous trough, or the top fills in the middle of the bottom. So I'm going to hit play here and just watch as the wave tops fill in each other's middle points. The bottom, top. Bottom, top. It's perfect. I don't even have to move my mouse. Again, I can just park my mouse over the wave top and the next one comes in. Well, the middle point fills in. That's what happened. The wave fills in the middle point of itself as it travels through the tank. Let me get this out of here. Hold on, let me close that. So as the wave travels across the tank, we're talking about Mother Nature's tank again, the red lines, so that we get the earthquakes dropped off all the way along the tank. And it's in like a day or two. It's not that long of a period of time. We're looking at 48 hours worth of earthquakes right here. And what you should be able to see, if you look at the magnitudes, They're all about the same size. We're looking at everything 2.0 and greater reported from the USGS and EMSC. And what do you see? Well, here, let me point it out to you in case you don't know what to see. 4.6, 4.5, and a deep 5.2 down below it. We also have it right next to it, a 4.9 and a 5.4. Now, these are just within a hair of a point of each other, 5.2 and 5.4. And these are within a hair of a point of each other, 4.6, 4.5. Now, 4.9, keep that number in mind. As we go to the west, 4.7, right here at Katovar in Papua New Guinea, and a 4.7 just north of it on the plate boundary that goes around this way, and that's right next to Guam. Going over to the west, 4.7 again, and another 4.7 that was downgraded to a 4.6. So that's really 4.7s. It doesn't stop there. We go over to the west, we have a deep 4.8, about the same size again. Then we go over to the west again, another 4.6, and we go to the west and we tail it off at a 4.9. So we have 4.9 and 4.9 on bookends. In between, 4.7s all the way across. Down below, a 4.8. Now we go to the north, and the same thing's going on. Take a look. 4.9 at Taiwan, 4.5 to 4.6 in South Japan. I'll wait for that to refresh here. Up to the north, 4.4 and 4.8. And then down below, we have a deep 5.8. That's pushing up right now. It just struck today. So a deep 5.8 down below this H-shaped bend at Japan means we have to warn the area around Japan for earthquake up to 1 magnitude larger. A shallower, larger earthquake would be due around where this H-shaped bend is. And then we can determine our areas by looking between our sets of current earthquakes over the last 48 hours. So looking at this, it's the standing wave, the same sized earthquakes going all the way across from Taiwan, 4.9, South Japan, 4.5, up north, 4.8, and a 4.4. So the middle of it all, look where they all overlap. All the rings overlap. Let me get a perfect center on it. They all overlap right here, right on the coast of Tokyo. Well, what's on the coast of Tokyo? It's the H-shaped bend of the plate. I hate to use the analogy in reference to Japan, but when we're talking about like this dividing line with 2 points on either side of it, it almost has a yin-yang-like shape to it. And I'm not trying to equate that to anything. I'm not just saying the shape is similar, that on both sides, you understand the shape of a yin-yang, right? It's like on both sides, it's an equal and opposite. Okay, well, that's what we're dealing with here. In the middle is where the stress is. The middle point where they overlap, and in this case, it's 4 or 5 different earthquakes. All the waves overlap at that middle point. So we warn for a up to 1 magnitude larger earthquake in Japan within the next 7 to 10 days from today. 7 days is the 20th, and 10 days is the 23rd. So by the 23rd, we should see a 6.8 somewhere in the upper 6 range strike right here. That means we need to warn the people in central Japan. Going up to the coast of Honshu, I try to get it within 200 miles. So let's just say 200 miles to 500 miles in each direction from the middle point here. So 200 to 500 to the north, 200, 500 to the south. To the south, ocean. To the north, coast. If I'm wrong, I would want it to be out in the ocean. If I'm off and it's further to the south or further to the north, we would want it to be far out in the ocean, not next to anybody. And of course, in the 6 range, it's not normally big enough to cause tsunamis. That's good too. Okay? What else is going on? United States. Dude, okay, I can spend an hour talking about the United States, and I probably should. Let's do it. Maybe not an hour, but let's just quickly get into it. Looking across the United States in the last 2 days, this is 2 days worth of quakes. Let's get all the small ones out of there and just look at the 3s. Okay, here we are, 3.0 and greater, going from the west coast to the Midwest in the course of 2 days' time. Now you should be able to notice they're all about the same size. That standing wave principle that I've talked about before, and again, I'm showing you everything 3.0 and greater. Let's look at 2.0 and greater. All it's going to do is fill in the middle points between the 3s because we're talking a standing wave. So that down point between the upper crests of the wave goes up and down, and along the slope I would figure, and that's a guess on my part at this point because I don't have any way to test it, that I would figure along that slope there's going to be 2s and 1s that go along the slopes between the 3s. Again, in that video I showed you with the waves that were going through the tank, that in between those waves, you're going to go down and then back up. So here we are. The spots which are being struck are weak points in the plate along the edge of the interior portion of the craton. Compare the earthquakes where they're striking to the craton diagram. The purple and the rusty brownish color. What you'll see is coming out of the northwest, going down across to the east by southeast, there's a diagonal line of small earthquakes that begins up in Montana of zeros and ones, goes down across the park at Yellowstone National Park, also makes an arrow shape of quakes going over across Utah, starting up at the Wasatch, oh boy, did I get that wrong? Okay, anyway, starting up at Salt Lake City. I think this is Wasatch. I get them all confused now. The two W's, okay. Anyway, down to the east by southeast, this is like an arrow shape, and that's why we have an arrow there across Utah. Now, out here at the pinnacle tip of the arrow is an oil pumping operation at Carbon County, Utah. All of this is drilled, and I can prove that. I can show that to you. Once we get down to the southwest portion of Utah, we're at the volcanic fields that spread across here, Uinkaret and the Markagunt Plateau. Over to the east, we're at a drill point in southeast Colorado, with the biggest earthquake of the day, well, I shouldn't say of the day, the biggest earthquake in the last 48 hours, because there was a similar-sized quake over on the west coast, just before. 3.6 to 3.8, there. So, 3.7 and a 3.6. You add them together, it equals 3.86, whatever. So we have two quakes in California, one's a 3.7, the other's a 3.6. Then we get the cumulative total striking over here to the east, and I almost just sneezed into the microphone. I apologize. But we're live. So 3.8 and 3.8, 3.7 and 3.6. They're the same size, and we're going across the plate in the course of a day. 2 days most. So all these points have something in common. I could start up here to the north, take you down through California, over to the east. The only one that is not directly at either a volcano or a drill point is the one over on the New Madrid seismic zone, just south of my location. I live in St. Louis, or just outside of St. Louis, and we have one lone 3 down there on the New Madrid. But all of these locations, up here to the north, this is directly above the deepest part of the center of the magma chamber for Yellowstone. Yellowstone over here at the park, of course, at the surface, but it goes down, the magma chamber goes down 30 kilometers and reaches down below Idaho, and the feeder comes from below Oregon. This is the center of the magma chamber itself, as measured by Earth-penetrating tomography, down below, of course. So the earthquakes are actually happening up above the magma chamber. The magma chamber going down 30 kilometers, and these earthquakes are happening more at like 10 and 5. So up above the magma chamber, on the edge of the craton, coming in from the northwest. And let me show you the smaller earthquakes again, so you can really piece this together. Here's everything 0.0 and greater in the last 48. It's so obvious. A diagonal line coming out of Montana going down across, and this arrow shape going across Utah, pointing over to Colorado. So if you're curious about the magma chamber for Yellowstone, you guys can go look that up. It was really interesting to see the Earth-penetrating tomography measurements. It's like a form of VLF. They use trucks to drive around and create a low frequency that basically vibrates and goes down and bounces off the inside of the magma chamber and comes back like a radar image almost. So that's where this struck. This line of quakes goes down along the edge of the craton, and we have another diagonal line of quakes coming out of the Puget Sound up here at the Strait of Juan de Fuca, going down across into, well, actually down into Oregon. But something strange happens once we get down into Oregon. It's very odd. Sometimes, almost all of the time, the earthquakes get reported as explosions. However, these are not getting reported as explosions. They're actually reporting quakes coming out of Oregon. When we go back up and look up the location, though, you're going to find out that this, in particular, is at Mount Hood, which is a volcano, a stratovolcano. The location's called Government Camp, but let me just show it to you where this little outbreak's taking place. And it's important to know where the small earthquakes are striking. It doesn't mean that this is going to erupt. It just means that there's a weak point in the plate that's getting hit as a flow of power or force is coming into the plate. Same reason that Yellowstone's getting hit. And it's the same reason we have clusters of red dots here. These red dots are hot spots detected by the weather satellite. The plate emits electromagnetic waves, which are picked up by the weather satellite up in space, and it reads them as fires. But these transfer, and it only happens when the plate is under tension. So you can see the hot spots match across Idaho, Montana, going down into Utah, making an arrow shape going over to the east, over into Colorado. Oh, yeah, sorry, guys. We got a cat toy clicking over here now. Okay, this is wonderful. And our mascot, Hans, is here with us. The cat's name's Hans, guys. It means God's graciousness. But anyway, stack of quakes across the plate coming in from the northwest lets us know the plate's being pushed. And it's coming from the northwest, so we know which way it's coming from. It's coming from the Juan de Fuca fracture zone and coming out of Alaska, which really, it's all just tied to this red-lined map that I've been showing you this whole update, coming in from the northwest and coming down into the Juan de Fuca, which has jagged edges of the Pacific plate. Here's the Pacific plate, and these jagged edges belong to the Pacific. They dig into or push into the North American plate across and into North America from the northwest. And that's kind of the shape that the arrows are taking here. Well, they're not arrows. These are the actual fracture zones. But you'll notice they're all kind of pointing in the direction of the way the earthquakes are coming from into the United States. So the jagged edges of the Juan de Fuca point into where the flow is going to. And then the flow goes to it and around it. And that's the amazing part. Now, I told you, volcanoes and drill points. Do you want to see them? Maybe there's going to be some people out there who are new and they don't believe or something. I'm just going to show you the largest earthquakes of the day. You guys can probably take the time, or should I show everybody? All the earthquakes. Because it really blows a lot of people's minds to see that almost all the locations are either directly tied to volcanoes or, in many cases, drill points. But we could just spend all night doing that, so let's do the stack locations. These are swarm locations. I've already showed you Mount Hood up here, and do I need to show you Mount Rainier and Mount St. Helens? I guess I would need to show you Mount Rainier and Mount St. Helens if you're not from here, the United States. But then again, there's going to be people in the U.S. who don't even know about Mount Rainier and Mount St. Helens. St. Helens erupted in 1980 when I was just a 4-year-old kid. I remember it covering our cars in light ash in St. Louis, Missouri, 1,500 miles away. Here we go. So, yeah, there we go. St. Helens, we're right inside the crater. Don't worry, it doesn't mean eruption. We're at the Rising Dome. The Rising Dome, which already erupted once, I think in 2007 or 2009 or something, put off a small blast out of there. And they got that on video on the USGS YouTube channel. But anyway, earthquake swarm inside there now just means the same thing that it does over at Yellowstone and the same thing it means down at Mount Hood. It means a flow is coming in from the northwest. Same with this cluster of earthquakes here. I'm going to pull an earthquake from the middle of the cluster, and this is going to take us right onto Mount Rainier, which is the other well-known stratovolcano up in the Pacific Northwest. You can see this from downtown Seattle, which we saw when we went up here taking radiation readings. We drove by, saw it off in the distance. I took radiation readings after the 2011 Japan Fukushima, whatever. I drove across the country taking radiation readings. Anyway, we're here on the side of Mount Rainier, and look, we got some hot spots at both volcanoes just to the south, detected by the weather satellite. Don't worry, it doesn't mean it's going to erupt. It's just, again, electromagnetic signals picked up by the weather satellite, emitted from Mother Earth, which is crazy, but there it is. So volcano, volcano, volcano up to the north. Once we get down here, what do you want to bet we're next to some more volcanoes? Let's go look. McCloud. We are at McCloud, California. What you are experiencing, McCloud, is called the quickening. Who wants to live forever? Come on, babe, sing it with me. Who wants to... I can't go that high. Live forever. Come on, guys. You got to have fun every once in a while, even when you're doing something live and serious like earthquakes. Now, here we are. We're on the side of Mount Shasta. Mount Shasta in McCloud. Well, guys, there it is. We're on the side of another stratovolcano. That's where the 1.7 is. Well, surely there's not a volcano down here in the valley Like, oh my god, at Palo Cedro, it's going to get down to the valley and it's going to have a volcano. That's a California joke, guys. Come on. Okay. We're going down into the north part of the valley. Look where we're going next to. And I'm serious. We're just like a mile and a half, 2 miles to the west. Maybe, well, actually, that's 5 miles. Black Butte Cone. Black Butte Cone. Black Butte, a pyroclastic cone west of Lassen National Park, was thought to be of a Holocene age, but later mapping indicates a late Pleistocene from Miller of 1989. This guy Miller went out to go debunk and prove that the volcanoes were older everywhere. And he did. He went out and proved all the volcanoes are way older. Anyway, there we go. We're on the side of it. Looks like they're doing a little scraping out of the volcano on the side. A little mining, probably gold. Other precious metals. But there we are. We're next to 2. Now, okay, that's now 2. Let's go over to the east. Mineral, California. There are minerals here, but you'll see why in a second. There's an abundance of rock as well. Flowing rock, hot flowing rock, called lava. It hardened over time on the side of Mount Lassen. You can see the lava flows. And you can see the old past bigger volcanic field all the way around it with its fresher lava flows, like Cinder Cone Butte State Park with hardly any trees growing on the lava itself. Go split 2 ways. Look at that. Isn't that cool? Came out of there, came out of the side. So this one was here first. Then it bust out the side at some point and put another lava flow, fresher, younger, out this way and went down there. And it barely has any trees on it. So that kind of lets you know how old it is. All right, so that's the third location. Do I need to keep going? The 1.1 is just a few miles to the east-southeast of where we were just looking. So, just right about here. Swain, on the side of Swain Mountain, which is another volcano, by the way. It's just even older. That one's fully covered in trees. Okay, over to the west. Have I proved my point in Northern California? Every location up there is a volcano, isn't it? It's undeniable. What about the big stack that draws your eye's attention right there? It's called the Geysers of California. It's a spot I've showed 1,000,000 times. Well, that's an exaggeration. Certainly over 1,000. Let's put it in and show you. It's a volcano called Clear Lake Volcano. Smithsonian has it marked here with the red triangle, Mount Canocti. And on the side of this, it's a large caldera, and on the side of it is Geyser Peak, where they've drilled in and they inject sewage to steam it off, to come up and turn these turbines to provide power for the area. And that's that. And that's where the swarm is. Now, there's a few oddballs, but they're not really odd. 2.4, 2.5, and a 1.1. Those 3 quakes are directly on the north arm of the San Andreas as it makes a turn and goes out into the Juan de Fuca fracture zone. Out there in the Juan de Fuca. So there we go. You like that? There we go. Over to the west. Check it out. It goes over to the west and dead ends into the southern arm of the Juan de Fuca. Goes down to the south and it goes all the way through California, the famous San Andreas fracture zone. But really, it's just the plate boundary between the Pacific and North America Laurentia. The continent is called Laurentia, in case you didn't know. The thick red line is where the earthquakes go down and across. And look, it's a perfect connect the dots across the creeping section of the San Andreas, here next to Monterey Bay, to the east of Monterey Bay, and here across the Hayward Fault. So how are the Hayward Fault and the San Andreas connected? Well, I'll show you right here. Here's the Bay Area, Hayward Fault coming out of here, going down and connecting into San Andreas. Take a look at the quakes. Same thing, right? But there's one that jumps over here into the valley and another that jumps over here off to the coast. If this is the San Andreas, which it is, show it to you again, right here. Earthquakes are coming down. All of a sudden, we jump over to here and down to here. Why? Well, you got to see what's at each location to understand why you're jumping over. So let's go take a look. Why are we jumping off the San Andreas and going over to Avenal, California? Well, when you see what's here, guys, if you're new, your mind's going to be blown. You're going to be like, what? I was. My mind was blown. I'm like, huh? Are you serious? You got to be kidding me. So take a look at it. Here's the coordinates for the quake, and I'm just going to zoom in, see where the nearest oil well that we can find. Well, okay, here's a pipeline transfer station, like a substation for pipeline, we need to go over here to our nearest oil well. There we are. There's our nearest oil well. So we have a whole bunch of them, like about 10,000 of them starting right here, where there's so many, they're numerous, they look like ants on the ground. And this is low up to here. Again, they look like ants on the ground. All the wells, all the drill points. But that's low in the number. Once we get down here, we get into hundreds of thousands. This is the San Andreas. And the earthquakes, let me hit search again, jump off the San Andreas, go over to here. To the nearest drill point, or one of the nearest drill points. Right next to it. Why? Well, path of least resistance. If this is under tension, and you have a drill point or a weak point next to it, the tension's going to transfer over to the weak point, just like a solid mass would. Now we go over on the west side. What's over along the coast? Go take a look. Well, let's get the coordinates from USGS. There we are. Cambria, California. And we're right along the coast. I believe there's faults here that many people might know about. San Luis Obispo Fault. Here we are. We've jumped off the San Andreas and we've gone over to the west. Ooh, what's this? Ooh, a Lime Mountain Company. Hold on, is this a quarry blast of some kind? No, 5.6 kilometers deep. Oh, man. Now, people might ask me, well, how could it be that a mine at the surface could cause an earthquake? And I would say there's many ways that that's possible, but the fault that's there would be at fault. No pun intended. Let's go show you. Jump right over here. Did I call it San Luis Obispo Fault? I stand corrected. It's the Cambria Fault. San Luis Obispo is just up here, just a little bit on the north side. Oh, no. Is he having a little... Is he going to throw up? Little hairball? His first hairball. On... recorded. Oh, this is perfect, guys. The cat's like 6 weeks old. He's having his first little... Maybe he's allergic to something. He sneezed earlier. Oh, that's adorable. Hold on, guys. Guys, I'm going to need to wrap it up. The cat's having a little issue. But here's the deal. The earthquakes go down across the San Andreas, jump over to the drill points. They try to go around and focus in down on Southern California. I'm not going to take the rest of this time to keep proving my case to you about the drill points or the volcanoes. I will tell you the clusters over to the east are at Long Valley Caldera, centered around the area south of Lake Tahoe. Is everything okay now? Okay. Hey, cat comes first, guys. This cat's like 6 weeks old at the most. Okay. Thank you for being in here, Duchess. The whole crowd. Weatherman's breaking off. He can't do the update anymore. The cat's having a problem. Gotta go. Oh, La Palma's gonna fracture in half? There's gonna be a 1,000-foot tsunami that comes into the East Coast? My cat. Gotta go take care of it. Peace out, guys. Oh, this is priceless, man. Okay, I am so saving this update and uploading it to YouTube at this point. That's it. There's no way around it. This is going on YouTube. It needs to be immortalized. Okay, so I can look up everything now? Okay, cool. All right, let's carry on. Class, you can't leave yet. Over here at the California border, I'm going to zoom in right in on the middle of it. We're going to pull the earthquakes right in the middle, and I'm going to show you what's all the way around it. This is interesting to me to see this cluster of quakes. Yeah, I'm going to jump back on and do it now. Yeah. Sorry. Okay. Viewers are just now catching up. They're like 30 seconds behind live. Here's the earthquake in the middle of this whole hot mess at the California-Nevada border. Again, I'm just zooming in on the middle of it, pulled the quake in the middle. You see there's a big ring all the way around the California-Nevada border. Well, what you also see is there's a computer-detected hotspot from the weather satellite here, and it's right next to Mono Lake, which is a volcanic field. The supervolcano, though, that I mentioned is right here. This is Long Valley Caldera. It's lined with other volcanoes, and it has 1,000 cubic kilometers of melt down below. Over to the east, we have another hotspot. This one's out here in the middle of nowhere out in the desert. And we have a bunch of volcanoes right there that make up the eastern side. Goes over to Monte Cristo Hills Volcanic Center. Got a 6.5 earthquake last year. And a fracture formed in the surface fissure fracture formed 12 to 13 miles long over to the west out of there. Now the earthquakes. Today, yesterday. Look at it. Now let me point out, up here we got a 6.5 earthquake like 3 weeks ago, almost a month ago. Maybe a little bit more than a month ago. Maybe it has been over in a month. Well, anyway, we got a 6-point-something earthquake here just recently, and then last year 6.5 earthquake here, and we already all know about down at Long Valley and Mammoth Mountain and Mammoth Lakes with its fives and swarms, which is right here. Here's Mammoth Mountain on the side of Long Valley Caldera. So let's just point that out. 6.5 over here, 6-point-something here, and a swarm here, going all the way around where the supervolcano is. We also have hot spots that accompany it. That means tension in the plate around the supervolcano, but it's the same reason, the same tension that's causing activity up here at Yellowstone and activity that's up here in Northern California and volcanic earthquake activity at Mount St. Helens, Mount Rainier, and Mount Hood. It doesn't mean that any of them are going to erupt. All of them are vulnerable points as the energy, the standing wave, is traveling across the plate, following across the craton edge. My whole point on showing you all this is that these weak points can be forecast for. You can know where to watch. You watch between our current sets of earthquakes for new breaks to take place. So when you see a cluster here, and you see a cluster here down at Ridgecrest, let me show you where the cluster at Ridgecrest is. I'm going to pull the coordinates from right in the middle, just like all the others. And, well, if I can here, copy and paste. Yeah, this is the most epic update ever, guys. It is. I appreciate you sticking through it. It's the first one I've done in God knows how long, almost a month on YouTube. Okay, so here we are. Where is this? You see these? These are not forest fire locations. These are all lava flows coming from Volcano Peak. So Volcano Peak here, and about 10 other eruptive points on the side of it. All the way down, separate eruptive points, different ages. Some of the flows are younger, some are older. But notice the line of volcanoes there. And let's go back and look at the quakes. It matches. We're pulling from right in the middle. So the line of quakes goes on the east side of those volcanoes, down in dead ends down here at Ridgecrest. It starts just a little bit to the north, right up about here. And guess what's there? Let me just show you. A volcanic field and this. So right here, all of this, geothermal drill points into a volcanic field. That's where the earthquakes start. They go down in a line on the east side of the volcanic field and dead end down at Ridgecrest, which is, we have to jump back to the USGS map now, right here. So we dead end into this. It's like a wall. The line of quakes comes down this way and dead ends into it. But I shouldn't say dead end. That's just where it meets into it, then transfers across and carries in across the Mojave and feeds into Southern California from the north. So you can see the line of quakes that does that goes across the Mojave and it comes in at a trajectory like all the others, northwest to southeast. Southern California, same thing. The trajectory of the quakes, all northwest to southeast. And they're all following this. The pattern of the faults and the plate boundaries. Are you shocked to find this out? That the earthquakes travel down and across something and follow the weak points that are in the plate? When I showed this to everyone, they denied it. They said I was faking the quakes. That's what they said. That was their best explanation at first. You must be faking the quakes. Yeah, hey, let's go over to the west. Go take a look. Pull the coordinates here from the USGS. Thousand Oaks, California is the location it's listed at. at 2.4 kilometer depth. But I'd like to go look it up, see what's there, see if there's anything of significance other than Thousand Oaks, California. There was a big fire there last year. Or was it 2 years ago now? Okay, there's the earthquake epicenter. And zooming in on the spot, I think I do see something right here on the north side of the mountain range that would draw anybody's eye. Oil wells, and lots of them. And I mean a lot. They go all the way across this entire front range. Take a look at it. You see the shadows of the jacks of the bumps, and you see how many there are just in this little patch right here, about 30 or 40 of them. We go across here, and we go over to more, another patch of like 30 or 40 of them, where there's 4, 5, and 6 per hilltop. And we go over to the west, and there's so many, it goes here. Let me just zoom in a little bit. All of these are not houses. These are all oil wells. And you go across the valley and you pick up on the other side of the valley right about in here. And you go over to the west and they carry on. All of these little pads in the mountains here. And again, they got 1, 2, 3, 4, 5 different drill points just on that one hilltop. They follow this range over across the valley again this way, in a line over towards Carpinteria and all of this offshore drilling. We go back over to the east, and you can follow them back through Ventura. All of these are drill points. And getting back to where the quake is, guys. Let's take a look. It's right there. Again, we're just within a matter of a couple miles for the biggest earthquake of the bunch out of the west coast, 3.6. Going down to the east by southeast. Do I need to carry on? Can we look up the rest? Carson, California. This location was previously drilled back in the early 1900s with hundreds, if not thousands, of drill points that only go down a few hundred feet. And I mean, there were so many here. There's pictures that are just impressive. Now it's all subdivisions and houses. There may still be oil wells scattered out throughout here. People still tell me that they see them. But now you're right next to a big refinery where they keep a lot of the oil and refining. That's just the tip of the iceberg. There may be, and I'm not kidding, there may be more drill points right down in here still. But I don't have them marked. That's a guess on my part. Okay, all I know is that this was formerly drilled. I have proof on that. We have pictures. People have sent me even awesome old photographs. They look like almost like cowboys out there, and they're still wearing like Texas-style rancher hats out there, but they're more of like a Mexican Texas style. And they're doing drilling with like wooden derricks. Anyway, over to the east, let's go. Sierra Madre, famous location for earthquakes. You guys may have heard of it before, Sierra Madre. There's other things here. Let's go take a look. How about a hotspot from yesterday? Anything else worth noting? Let's go see. Sometimes there's power lines. Other times there's high frequency or high power radio towers that are nearby. Radar stations sometimes. In this case, we're directly on the Sierra Madre. I had to go look. I don't know what's at each of these locations. I have to look up myself. The only ones I know are the ones I have to look up repeatedly. Once we get over here to the east, we go in a diagonal line. This follows the San Andreas right here, branching off the San Andreas, going around Salton Sea, and that goes on to the San Jacinto Fault. And that's that right there on the west side of Salton Sea, which I can show you on the USGS map here as this line right there. So let's recap now that your mind is totally numb from earthquakes and me showing you all the spots across here, being at either volcanoes, drill points, or a few are at faults connecting between them. But starting up to the north, let's just recap. Diagonal line of quakes going right down into Mount Rainier, Mount St. Helens, and Mount Hood. Then another diagonal line of quakes coming in from the northwest, going across Montana, going down into the magma chamber for Yellowstone, resulting in 3.0 range activity above the center of the magma chamber for Yellowstone. Another diagonal line of quakes coming in from the northwest, going across Northern California, all at volcanoes. Another diagonal line of quakes coming in from the northwest, coming off the Juan de Fuca fracture zone, going down through a volcano at Clear Lake, then going through the Hayward Fault, going down across the San Andreas, jumping off to a drill point over to the east, And over to the west, but arguably over to the west, you're strictly on a fault, but we're getting really close. Over to the east in eastern California at the California-Nevada border, another diagonal line of quakes going northwest to southeast, this one going right across the supervolcano where we have clusters on all three sides, where all three sides have been hit by major earthquake activity in the last 2 years. And in the last year, well, not even. In the last few months, a big increase has taken place all the way across here, just in the number of earthquakes. What's causing that? I mean, it's a weak point. Is it going to erupt? I don't think so. I think we'll get a warning sign of tens of thousands of small earthquakes, not just a few dozen. Down to the south, right next to drill points at the 3.6, and at the old oil fields, Carson, go check it out, in LA. And then over to the east, I didn't bother looking any more of these up, but they're strictly on the fault zone connecting down into Southern California's border. Now that fault zone, the San Jacinto, it's the path of least resistance around Salton Sea. It takes more energy to move the San Andreas than it does to move these smaller faults. Are you surprised by that? So this force or energy will take a path of least resistance around a smaller fault as opposed to go down a major one that's harder to move. Now I mentioned over to the east that we're in Utah at volcanoes down in southwest Utah, and up in northeast Utah, we're at drill points. You guys can go check that out if you want to. You can go look up Magna, Utah, for instance. Thatcher, Utah. Here, let's go pull the coordinates. Why not here? Okay, why not? All kinds of bunkers here, actually. Bunkers. You're calling bonkers. There we are. Penrose. What is all this? What are those? How about deep mining points and the conveyor belts to take the mined material off and take it for extraction? How about going down deep, deep, deep into the earth here? How about an earthquake there? How about that being Salt Lake? Hashtag Tartaria. Down to the south we go. We go down here into central Utah, going into southern Utah. Volcanoes. Let's go prove that. Milford, Utah. We're actually above sea level with a negative 0.1 kilometer depth, but this just means we're up inside of a mountain. So let's show you what's there. Milford. Milford. Right next to Milford, we've got unmarked volcano. Crater Knoll is the name of it. Now, why wouldn't they have that marked as a volcano? Again, well, this is from the University of Utah. Check it out. So, Crater Knoll. We are right on the side of an ancient volcano. You can see where there was an actual old lava flow that came out of there a long time ago. Anyway, there we are, Crater Knoll, and then you have the greater Smithsonian-marked Mineral Mountains Cove Fort Volcanic Field, which I think Crater Knoll is a part of. Anyway, we got a hotspot there, too, from a weather satellite picking up electromagnetic disturbance. Down in far, far, far southwest Utah, we go down to Veyo, Utah. Veyo, Utah. Have you ever heard of it before? I have. It's because there's something cool there. Something really cool. Take a look. An earthquake location from a long time ago. No, we're on the side of a volcanic field. Here, Santa Clara Volcanic Cone. Let's show you what they look like. We got a highway that goes right alongside of it. Look at that. So somewhat of a fresh cone, but they've scraped out the side looking for something. Gold. But you see this. This drives right alongside of the lava flow. I wonder if we can get a street level. Wow. Which one should we do? Let's go the one where we drive between the lava flows. See if we can see it from the road. Yeah, you sure can. It's higher than the road. Look at that small butte off to the side there. Wow. Look at the lava there. So you can see where it kind of stops. It's not that, I would say, arguably, it's not that old. I mean, in consideration, geologically speaking, they would say millions or something. I would probably say thousands. There we are. Amazing, right? Okay, let's exit that. And again, you saw that right there. That's a little spatter cone that picked up on the side. Imagine over in Hawaii or over in Iceland is another good example. But we're not on the direct plate boundary, of course. We're on the interior of the plate. But think of the volcano in Iceland and it flowing out. That's kind of what that flow looks like there. Where else do we need to go? Oh, yeah, hold on. We got a lone quake out here in south central Nevada. Rachel, Nevada. I do believe we've looked this location up before. Long-time viewers, it's been a minute. Let's go take a look. I wonder what's there out here in the middle of nowhere. Ah, the very famous Area 51. That's where we are. The earthquake is there. Is it an explosion of some kind? Nope. It's at the surface, though. It's not listed as an explosion. But, come on. We're on the side of Area 51. What do you think they're doing out there? That would be a case where I would actually think it was a sonic boom. First time ever. A real legit sonic boom. Anyway, that's where the 1.0 quake is. The rest, let's go over to the east. The biggest earthquake of the day for the whole continent, a near 4, southeast Colorado. Now, why would it be in South Colorado at all? Look at the craton diagram, guys. Look at Colorado. Okay, obviously, the craton goes right down through the Continental Divide, down through the mountain range, goes down through New Mexico and makes a bend into Texas. And that's where we get the other same-sized quake, 3.8. So it's two 3.8s. One on the edge of the craton down in Texas, the other on the edge of the craton going into Colorado. Now, we all know about Texas and all the thousands of drill points down there, which I'm going to prove to you the 3.8 is directly next to one. But what about Colorado? Most people don't think about Colorado being big-time oil production, but man, guys, there's a lot. I don't know what's at this location, though, so I have to look it up just to make sure. Is there oil or is there a volcano there? Now, this is for cattle. That's not any kind of drill point or anything like that. What we would look for are pads that are set out into the countryside that have pipelines that go to them. This looks like a farm to me. Yeah, okay. And so when we don't see that, back it out, take a look at the greater area. Any drill points there? No. We have the marked volcanoes of Colorado. Yeah, and a couple detected hotspots from the weather satellite there. Well, isn't that just very interesting? So hold on. Do you know about the volcanoes here in southern Colorado going into Oklahoma? Here's Oklahoma's panhandle, here's South Kansas, and here are all the volcanoes. So let's just zoom in on one of the close ones. Wait, hold on. Oil or gas? Well, oh, wow, okay. Yeah. That's a lambda symbol. That's a giant lambda symbol. Ha! Yeah. Okay. So we're on the side of a volcanic field. Carrizo Mountain is a lava flow. Here's one example. So this is a butte. It's been blown away over time into a mesa, but on the top of it is the actual old remnant cone. This is the top basalt, black basalt. That's the lava flow that comes off, and it's been mesa'd out over time from weathering, from wind. And these may have even formed when there was a lot of water in here, letting you know how far back the formation of those go. That's where the volcano is. That's where the earthquake is. Looking for drill points. By the way, the reason I was looking for drill points, let me show you why. Hold on. The reason I even brought it up. All these little pads in the mountains here are different oil and gas pumping operations across southern Colorado. They have the same thing up in northern Colorado. And I mean a lot of them. Look how many there are. If this isn't clear-cut forestry, this isn't for camping, these are not houses. These are all oil wells. This is southern Colorado, down at Trinidad, going down to the New Mexico border. It carries on across the border, down into New Mexico with the same size. All of these. Okay? And so that's why I'm looking right over here for potential pumping operations, because I know right over here there are. It's just a matter of, are there some over here on this side? There could very well be, and I'm just missing them from not being, astute and looking. It takes a long time to identify oil pumping operations, guys. It really does when you don't have a list to go on. Well, here's a pipeline right here. Hold on. Oh, we got a pump right here. We got a jack right there. That's what I'm talking about. So we'd have to follow the pipeline across these fields. This is some serious sleuth work that you have to do. You have to follow the pipelines across the field, and then you're going to get to other points that feed into it. So the pipeline going this way right across the field, it wouldn't surprise me if there are some other wells that are out here that, again, they're so small, trying to find them by hand like this, it takes me hours to find them. So unless there's a well right there, I look at the volcanoes. Good real-time example for you. Now here's a spot where there's going to be no question. This is down into Texas. It looks like the cat got the little thing again. Well, that's the way it's going to go. Maybe the little thing is needing to be turned off. I don't know. Do we need to turn it off? Can we turn off the fish? It's a fish. It's a USB charged fish that when it senses motion, the fish wiggles. Okay. See this pond here? This is what's called a fracking pond. What a nice transition. What a nice transition from the USB fish to the fracking pond. Now, they don't fill this with nasty water. They line it so they can collect as much fresh water as they can for free from Mother Nature. And then they take it, mix it with toxic chemicals, and pump it down into the ground to break apart shale. They leave the nasty stuff down in the ground. Let the oil and gas come up. They call it wastewater disposal. But it's just a version of fracking to get more oil and gas out of old wells. And look how many wells there are here. Now, I don't know if you know what to look for, but I'll just give you an example. These. Do you see them all? And how they just go on and on. These aren't houses or anything like that. This is not a town. These are all oil wells. I'm going to back it out and show you how many there are. You just keep going down this way. There's just literally hundreds of thousands, if not millions, of drill points just through a few of these counties here. Whole counties done. Whole Texas counties, which we know are just massive in their own right. And they just done it the whole way, all the way across. Let me show you what a town looks like, just so you can see. Like, here's one of the bigger towns in the area, Odessa, Texas. And then around Odessa, you see, there's the pumping operations. So all that's drilled, and lo and behold, we got the same-sized earthquake that's striking up at the volcanoes in southern Colorado, right next to the drill points, most likely in Colorado. I can't prove that yet, but same-size quake. Well, what about over here in central Texas? I mean, central Texas is really just the southern arm of the Craton, too. So, Herm Lake, Texas. Okay. I hope I'm saying that right. I'm from Missouri. I don't know how to say it proper. Depending on where you are in Missouri, you're going to have to say it one way or the other. And we're at Snyder, Texas, where the whole mess began for me in Texas about 8 years ago. A series of earthquakes struck here next to Snyder, Texas, and I zoomed in on the spot, and it was right here. It was right next to here. So all of these were drill points. Now, this is 8 years ago. I zoomed in on it. We didn't have as high resolution. And I noted that there were oil wells there, and the earthquake swarm at Snyder, Texas, had to be related to the drill points that were there. And the Texas Railroad Commission got involved. They're the people who are actually the people who authorize the drill points in Texas, the Railroad Commission. But they and a few professors got involved and said there were no relation between earthquakes and drill points, especially oil and or fracking, and that there was just conspiracy talk online. I was the only person talking about it, by the way. So, I mean, they were talking about me, I guess. And they denied it. They said there was no relation. And that was 8 years ago. Then a huge series of quakes struck, fives, record-breaking quakes across Kansas and Oklahoma and Arkansas and going even into Texas itself with fours and fives, even close to fives, 4.9. And they still tried to deny it. They still tried to deny a relation between the drill points. Their last stance on it, I think, was that there was still no relation between the drill points and earthquakes. But here we are again at another drill point, right along the edge of the Craton, where, again, force is transferring across a plate, and it's hitting at the weak points, whether they're volcanoes, drill points, fault zone. It's force going across the plate. That's what's going on here. So I just proved to you that volcano in southern Colorado, same size as the earthquake striking on the edge of the Craton down in Texas, both are weak points from either Mother Nature or man. They're punch points in the plate. One from a volcano from down below, one from humans from up above. thousands of drill points from humans up above, or maybe one to a few hundred punch points from down below a volcano. Now, we go over into Oklahoma, and I shouldn't need to waste too much time looking up the quakes across Oklahoma. Everybody knows about Oklahoma and the activity there. So let's go just pull the biggest swarm of the bunch and show you what's going on there if you're new. It's like Texas, but newer. So Texas has these millions of drill points. Oklahoma's catching up. They were at 500-something thousand different drill points across Oklahoma in the past few years. And we're not let down. Here's the earthquake epicenter. We have previous 4.0 range activity right across the little river right here, our last marked wells. Fracking in this case. Wastewater disposal in a lot of cases. And they're all across here. So they're somewhat a little bit more spaced out than in Texas right now, because they only have 500,000 as opposed to Texas with millions. And we go up to the north and we got a whole line of them down the road. Every one of these a different drill point and a different set of tanks and pumps and jacks and pipelines. Okay, now you get the picture. So summing it all up, a flow going across the plate. Volcanoes, drill points. Volcanoes, drill points. Once you get here, you get a 3 on the New Madrid seismic zone. What's there? No drill points. No volcanoes. It's the middle of the N-shape bend. It's like a cursive N shape, isn't it? But if you go over and look on Google Earth, you can actually see the same shape in the plate. And look what we have in the middle of the letter N. You see that? See all those red dots? All those red dots are picked up by the weather satellite. The whole New Madrid seismic zone's under serious tension. And it's being picked up with all these little heat signatures. Now, when we first found these heat signatures, this was happening several years ago. And people tried to say it was farmers burning their fields. It didn't matter. It went on for the entire winter. And they still said it was farmers burning their fields. Well, I got news for everybody. It's not farmers burning their fields now. You know how we know? The computer's filtering every one of them out, saying it's not a fire at all. Just a chance coincidence, mistake pickup of hotspots across the New Madrid seismic zone. So you can't say it's fires. The computer says every one of them's not. Well, almost every one of them. And so, I would say, tension in the New Madrid seismic zone. Earthquake in the New Madrid seismic zone, 3.0. Last week, I issued the warning for 3.0 earthquake activity, or bigger, maybe even up to 4, to strike on the New Madrid. Here we are, and now 3 is struck. The flow has come across the plate. It's 4s on the west, well, 3.8s. Texas, Colorado, and 3s in the middle. We go back out to the west coast, and, well, we get back to the 4s that struck at the start of the week, which struck out off the west coast of Oregon. I don't even know. Yeah, 4.4. Yeah, let me get that on the screen here. There we are. So looking at the 4s and greater, you'll see the spread going across the Craton, going over to Texas. Pretty obvious. 4.4 on the west coast. 3.8 pretty much going across the California-Nevada border. Again, if you add these two together, 3.7 at the California-Nevada border plus the 3.6, it equals 3.86. Why does that matter? Because then we get 3.8 and 3.8 striking over to the east. It's been a wild week. I mean, down in Mexico, we got a 7. Supposed tsunami. I don't know about all that, but I know a 7 struck and I couldn't access the info for a couple hours. I was blocked. Long story on that. Let's get back to where we started the whole update. Over here, La Palma, La Cumbre Vieja. You know what? I said I wasn't going to do it, but I think we probably should look up La Palma. Let's just see what the media says. La Palma, also known as San Miguel de La Palma, is the most northwesterly island of the Canary Islands, Spain. La Palma is an acre, 708 square kilometers, 273 square miles, making it the 5th largest of the 8 main Canary Islands. Of course, we all know that. Here's the news. Yellow alert for Cumbre Vieja declared. The strong earthquake swarm is continuing beneath Cumbre Vieja, and now PEVOLCA, I guess there's a volcanic agency there, has raised the alert level to yellow, citing the repeated occurrence of the earthquake swarms since 2017, with this one being the strongest and also the shallowest, suggesting magma is slowly rising into the edifice. Measurements of helium-3 gas flux are also indicating this. Helium-3? Doesn't that show up before a sudden eruption? Let's see. It's not possible to say at this stage, is what they're saying. La Cumbre Vieja volcano last year erupted in 1971 is considered one of those active volcanoes in the Canary Islands. I don't know if that's the one with the crack across it. I would have to go look up. Again, I'm not an expert on La Palma, guys. I would have to look up, but that may be a separate island entirely. La Palma fracture. Let's see what that brings up. Oh, palm fractures. Cumbre Vieja. Look, it's been deleted from PMC. University of California, Southern California. Are you kidding me? They deleted it. Wow, they deleted the study. Well, we got the name. It's from 1983. Okay. Helens is the name of the author. We're going to have to go find this one. Now I'm intrigued. When I see that they've deleted something about a potential something or other. Okay, this was by Helens, correct? Yes, Helens. cityofboston.gov has it. Is that right? Wow, they really do. Boston's got it. Of course Boston's got it. It's the East Coast. If there's going to be a tsunami, you would want to know about that. Wow. Yeah, so this page has been deleted. Well, hey, now we know why they're deleting it. It gives you all the information you would ever want on it, on a spread of a potential collapse at Cumbre Vieja, and which way the wave would propagate. Well, I'm going to have to read up on that. But the fact that it was deleted off one site, in EDU, and they delete it, I don't like that. On that note, guys, I'm going to encourage you right now, you need to have an earthquake plan. I didn't cover the earthquakes over in Europe. Should I do that too? I mean, this is going to turn into the longest update ever. Let's just quickly sum it up. Earthquakes go from the West Pacific and transfer across those red lines that I've been showing you this whole dang update. The red lines around the planet. The standing wave in the tank, spreading. And it goes over and it follows out of the West Pacific and goes across here, over into Europe, into the W-shaped bend of the Mediterranean. Then it goes up across Europe, and USGS map doesn't help us from there. From the point where it goes into Europe, we have a three-pronged arrow system showing us which way to expect the flow to go. Three ways. One around the outside edge of Europe, around the craton of Europe, dropping off quakes around Romania, Poland, and all the way up here, for instance, next to my people, Holland and Denmark, North Germany. And then another way the quakes take is right up across the plate boundary, dead-ending into North Italy, between Turin and Milan. And a third way the earthquakes take, brute force, dead end, right into the middle of Central Europe and break apart and then go around both of those other two ways that I told you. So it's like a flowing river where Europe is the rock and the flow is trying to go around it. And there's one way out, pretty much, on the plate boundary. That's over to the west. And the quake struck last week, well, 2 weeks almost, 2 weeks straight of quakes here, plus a big one, bigger noteworthy size earthquake there, plus a bunch of smaller activity at Gibraltar. It kept going and going and going and going and going. Now, boom. So it's transferred from Straits of Gibraltar out over to La Palma. Now the worry is that it's going to erupt or that it's going to break and cause a tsunami. That's not my worry. That is the worry of like 10,000 professionals and 100 hours of Discovery Channel disaster shows. And I don't like covering that. But I am going to tell you, if it starts to go, you will have the speed of a jetliner wave that leaves here and travels at the speed of a jetliner as it spreads out across. And then when it gets in here to the west coast or east coast of the United States over to the west, when it goes over to the west and reaches the east coast of the U.S., it slows down, rises, and they're saying 500 to 1,000 foot high is what to expect if this thing actually collapses and falls into the ocean. Maybe bigger. If that happens, kiss the entire United States East Coast goodbye. Probably even get some water over here in Missouri. So, that being said, let's just hope it doesn't happen. Because I don't really have too much to offer on that except for just speculation and talk just like all the professionals did and all their fear-mongering Discovery Channel. It's not a matter of if, it's a matter of when. Dun dun dun, right? I mean, that's what they do. So, I'm not going to do that, even though I just did it as a impersonation. So let me just remind you, you need to have an earthquake plan. You need to have a tsunami evacuation plan. And you would need to be able to hightail it out at a moment's notice. As soon as I either notify you or you get a notice, you would have to start heading to a high point over 500 to 1,000 feet high. How do you find areas that are over 1,000 feet high? The way I would do it is use Google Earth. I would use Google Earth. I would look down here in the lower right-hand corner where it says elevation, E-L-E-V, and I would move my mouse. Let's say I lived in Virginia, right here along the coast, and there was a worry of a tsunami coming in. It was going to be 500 to 1,000 feet high. We're going to need to be higher than 500 feet. So moving my mouse, look in the lower right-hand corner. We're going 300, 400. Here's 500. This is 500 feet. And let's say it was 1,000 feet high. Well, you have to get up to one of these peaks. Once you get beyond there, you start getting up to 2,000, 1,900, 2,000. This would block most of it, but it would flow along here. And you want to bet that that's happened before? Take a look at it. Doesn't it look like water has flowed along here before? What would you do if I told you that at some point in the past, a big wave did come in and went right down along through here and flowed that way? And maybe even from the south too. Anyway, that's just, again, speculation. Maybe. We don't like doing maybes. You guys have an earthquake plan. Have an evacuation plan. Know your elevation. Know how to get out quick. Be able to do it before everybody else. That is the key. If you're going to be evacuating, you got to get to the roads before everybody clogs them up. All right. Now, that's up to you. I would tell you to have an emergency kit. That's a good idea. It's just got all the basic stuff in it. Change of clothes, set of shoes, extra IDs, extra keys, all the stuff you need. Because in a few minutes' time, if you only get a few minutes warning and you don't have that stuff, you're going to be running around your house trying to gather the important things plus the stuff that doesn't really matter but that you need. So you'll be trying to find your purse and your wallet while you're also trying to collect the cats and your photo albums or something. It'd be better to have all that stuff like the IDs and the documents and all that in a bag already ready to go. Even extra debit cards and maybe even extra wallet and the whole bit. But the basics, have that met in a bag so that if you have only a few minutes. The people in California are a perfect example with those fire evacuations. You only get a few minutes to get out. And some people were just like, they gave examples of what they were grabbing in a few minutes, and it was like their sunglasses, just a cooler with some food in it. I'm like, you got to be kidding me. And then they're leaving like their family heirlooms, It's just, don't be that person. Have a plan, be prepared as best you can. Now, for the 1,000-foot tall tsunami wave, come on, man. I think this is just going to be a swarm at La Palma. It's going to transfer out of here. If it sticks in there, then I'll worry. I really will. If it sticks around here for a long period of time, I'll worry. But I'm going to start to look for it to go out to the west, out towards the Azores, and a new swarm to strike out there. That's what we want to see. That's what normally should happen. It's not like this is the first time that there's been a swarm at La Palma or in the Canaries. There's been many other swarms here, guys. So it doesn't mean fracture. Don't let somebody on YouTube or anywhere else tell you it means that it's going to break apart right now. We've seen other swarms that are bigger earthquakes down there too, I think in the 4 and 5 range. So we've even seen that. I just have to bring it to your attention. That's what they're talking about, that they've raised the alert level, which is the change from the past. Okay? Doesn't mean it's going to happen. It just means alert level's been raised. And I'm watching it. Everybody else is watching it. Hence the update tonight. The other stuff that's going on has to do with the deep earthquakes. And I would even say that maybe the earthquakes over here, not maybe, I mean, it's tacitly involved, that the deep earthquakes are displacing the whole planet. We just had the biggest earthquake in years. 8.0 range. Two of them. Two back-to-back 8s. Come on. And then, all of a sudden, on the opposite side of the planet, we start seeing a volcano that we never really hear about much, and everybody's worried about, though. We start seeing that one? The only thing I haven't mentioned yet is North Pole. Svalbard has been hit all the way up here in the Arctic Circle. That's really just the North Mid-Atlantic Ridge, and it's the same size that came out of Europe, so you shouldn't be shocked. It's a transfer. Look which way our arrows point. Follow the arrow back. Transfers back down to here. Follow that back. Transfers back down to here. Do you see the flow? Okay. Anyway, wasting a lot of time now, but hey, this was a long, epic update that needed to be done. Fist pump to the air. Yeah, I was in Saturday detention. That's exactly where I was. The nerd, the geek, the jock, and the goth were all in there together on the... Principals got us. We snuck off to the locker. You know what that means. And on that note, you guys, be safe. I'm going to save this. Go upload it to YouTube. Cat interruptions and all. Looks like the cat's started to finally putter out here. Peace out.